Again, so last time we talked about balance and unbalanced forces, and we said that when we say balanced forces, that means we have forces that are gonna balance each other and they will gonna cancel each other out. All right, so example on that is the gravity force and the normal force. The gravity force that is acting downwards, and the normal force that is kind of acting upwards. Now let's see what is the meaning of forces. All right, so the title is The Meaning of Force. The meaning of force. So we all know, we've learned this, and it's just common sense that the force is a push or pull. So it's either a force that is push or pull that acts upon an object, all right? So there will be kind of interaction between them, but not all forces has to have that contact or that interaction with the other object. And that's what we're gonna write about. So let's see, a force is a push or pull upon an object resulting from interaction between one another. So whenever there is an interaction, then there is a force. All right. When there is no more interaction, then there is no force and there is no movement. All right. So all forces or the interactions between objects can be placed into two categories. So we have two different categories for forces. So I'm just gonna write forces can be either contact forces, so we might have contact forces, or we might have forces resulting from action at a distance. Forces resulting from action. What does that mean? From action at a distance. So I want to keep working on, the kind of the lines in here. So when we say contact forces, if you think about it, what are the contact forces we have? Things we live in our everyday life, right? Things exist probably every minute of your life. Hopefully you said the right one. One of them is frictional force, right? When there's a friction, if you're playing basketball, if you're playing football, if you're driving a car, all these, they have the frictional forces. If we're talking about a rope, when you're exercising with the rope, there is that tension force. And there is the force that we talked about, which is always there, and it cancels out with the gravity force or gravitational force. And this is the normal force that most of the time it is upwards, or I should say it's the opposite, in the opposite direction of the gravitational force. We have something that probably, especially when it's windy, when it's called the air resistance force. Because remember, when there is wind, the wind is really touching that object. That's why the object would move, or your hair would fly, or, you know. All right. So we also we can talk about applied force. And the applied force is, let's say you put your hand on someone and you push them, that's an applied force. And there's the spring force. All right, let's have a few examples on forces resulting from action at a distance. Now, if you think about it, we have forces that really do not interact with each other. However, they have a huge force on each other. And hopefully you guessed this right. And one of them is the gravitational force. Another example would be the electric force. And we're going to have, that's my favorite unit. Electricity is really my favorite unit. We'll get to it second semester. All right, what else do we have? We have actually something very important, that's how the universe is actually moving, which is magnetic force. Okay, so these are some examples on action at a distance forces. All right. So when we talk about force, how do we measure force? Everything has a measure. Everything has a unit, right? So how do we measure forces? I think this is something you've learned before. But we're going to do it again. We're going to talk about it. It's actually so force. Let's just write this down. Force is a quantity that is measured using the standard metric unit Newton. And remember, we're still in that Newton unit. All right, so forces are measured in Newton. All right, what else do we know about forces? A force is a vector quantity that has, when we talk about vectors, we talk about magnitude and direction. Okay, so it really matters the direction of the force, because it's going to be either positive or a negative value. All right, let's just have a little bit of example here. So we have an example. Let's say I have a book, whatever, sitting on a table. That's your physics book. And we know that there's a gravitational force acting downwards, right, with a measure of 20 Newton. So you should automatically know that there is another force, which is the normal force going upwards, and you should know that this value is also going to be 20 Newton. So what's going to happen here? We have 20 upwards, and we have 20, I should say Newton, downwards. So in other words, I have that 20 upward minus that 20 downward, which will give me 0 Newton. That is why there would be, this is called the balanced force. Let's just do example 1 here. That is a balanced force, Newton's first law. First law of motion is applied into that one. Okay, we're gonna different example. We got example number 2. What do you have here? You also have a table, and there's a book on the table. And you have that force, the gravity pulls down with Fg is the force of gravity. I would say it's 20 Newton. You should automatically know that there is an upward force. Table pushes upward. And of course, it's going to be the same force. And now we have a friction that is pushing leftwards. So that's the force of friction. I would say 5 Newton, whatever it is. So what's happening here? So we have 1, 2, 3 forces, okay? So I'm going to say that the sum, that means the sum of all the forces, or I can say the net forces is, let's do it step by step, F1 plus F2 plus F3, because I have 3 forces. Now, this one is pulling downward, then I know this is negative, right? Because we know that force is a vector, and the vector means that the magnitude really matters. And this is going to be positive, and this is going to the left, so that's a negative. So the net force is, you can do 20, that's F1, plus, now this is a negative, so I'm going to do it minus 20, and then minus 5. So the net force, 20 and 20 cross out, is negative 5, which means that the book is moving or acting 5 newtons to the left. So in this case, I have something that is called, what do we call this? Unbalanced force. Because not all the forces really acted upon each other. Not all the forces canceled out each other. Okay? So for that reason, we would say this is an unbalanced force. Okay, and when we talk about the unbalanced force, we are talking about Newton's. You know what, let me not get there. Let me just do it step by step. So now we're going to see what are the types of the forces. If you want to define each one of them before I move on to, the bigger picture, I just want you to learn about the names of the forces that we have, or the ones that we're going to be working on. It's basically the ones that we talked about earlier, which is the contact forces versus the forces that are not in contact. All right, just the definition, but you have to have a full understanding on the types of these forces. So if we talk, let's do this. Let's do types of forces. You will be tested on this. So, and the symbols. Let's do symbols here. Okay. And I'm just going to draw a line in between. And another one here. So I'm going to have 3 columns. And then the last one will be the description of forces. Okay. Oops, sorry. All right, so the first force we're going to talk about is, we already had a few examples on this, but let's do FAPP. What does that mean? That means we are talking about applied force. Okay? It's a force that is applied to an object by a person or another object. So it's a push or pull force applied to an object by another object or person. Okay? So this is the definition of applied or of an applied force. Now, one of the forces that's keeping us all moving is the gravity force. And we will represent this with F, G, R, A, V. I don't know if you can see that really good. All right, that's called the gravity force. And what do we mean by a gravity force? It's the force of gravity is the force which the Earth, Moon, or other objects attract another object towards itself. Okay? And it's directed towards the center of the Earth. It's directed towards the center of the Earth. Okay? And it's given that we know that the force of gravity is the mass times the gravity. So the force is mass times 9.8 because we know that the gravity measures 9.8 Newton per kilograms And I said before that you can say G is approximately 10 newtons per kilograms. So whatever would make your calculation easier, because the error is going to be really small that you can't really recognize whether it's 9.8 or you put 10. So even if it's not given to you in the question, you should automatically know that the force of gravity or the gravity force is, you can substitute either 9.8 or 10 for the gravity force. All right, let me just write, also known as, let me write this here. This is also known as weight. Okay. All right, let's talk about force that we talked about already, which is the normal force. That's the abbreviation with F, N-O-R-M, which is the normal force. And what does it mean when we say a normal force? It is the support force that is exerted upon an object just so that it can keep that object in a constant or stable position. So let's write this down. It's the normal force is the support force exerted upon an object that is in contact with another stable object. And we talked about the example of the book on the table and how the other force acts, the normal force acts exactly the opposite of the direction of the gravitational force. All right, I'm going to just do the same column in the other page. And we're going to go here with symbols and types of forces and description of forces. And I'm just going to draw that line. Now we're going to talk about a frictional force. I mean, if you think about it, a frictional force, it kind of explains itself. Okay, so what do I mean by frictional force? First of all, we represent it with F and FR. I mean, you can put FI, FRICT, and that is called the friction force. And what is the friction force? There are two types of friction force. There are two types of friction force. The first one, which is the sliding force, and the other one is the static friction force. Okay? So the thing about the friction force, whether we're talking about static or sliding force, the friction force always acts the opposite side of the motion of the opposite side of the motion of the object that is moving. So let's write this down. The friction force always. So highlight always, because It doesn't matter what force you're giving. Just when you hear the word friction, you should automatically know that we're talking about an opposite direction of the motion of the object. Always oppose, well, the motion of an object. Okay? So friction is usually from when two surfaces being pressed together closely. That's when friction forces are created. All right, so the friction force depends actually on the nature of the two surfaces. So let's write this, that friction force depends on the nature of the two surfaces upon the degree of how pressed together they are. Okay, so the formula for the friction force, I don't want you to really memorize it now, but I'm just gonna put it down there. We're gonna learn it later. I'm just gonna put it here. That's the surface times the, that should be NORM times the normal force. Okay? Let's talk now about air resistance force. It's the F air, which is the air resistance force. And what do we mean by the air resistance force? It acts upon objects as they travel through the air. So it acts upon objects as they travel through the air. All right, so air resistance is most of the time also in the opposite direction of the motion of the object. So it's often, not always, it's often observed to oppose the motion of an object. Okay? Usually it's really neglected because the magnitude is extremely small. What I mean by neglected is that we do not calculate it when we're looking for the net force because it's usually really too small to really affect my net force value. All right, so it's most of the time it is most we mostly notice it when we're going in a very high speed, like skydiving, for example. That's when we can feel the air resistance, and that's when the air resistance math or calculation will make a big difference. So I'm gonna say it's most noticeable for objects that travel at high speed. Okay. We're gonna talk about two more and then I'm gonna end this recording. All right, we will talk about the tension force, and that's FTENS. I'm gonna call this tension force. So it's transmitted through a string or a rope or a cable. It is just like the normal force that acts in the opposite direction of the gravity force, but the difference is that this one, when we talk tension, then we should automatically know that we're referring to a string, rope, cable, or something similar to that. The last one is going to be your spring force. And what is the spring force? Just the way you hear it is the force exerted by a compression or a stretching of a spring. So exerted by a compressed or stretched. Wait, I feel I spelled that wrong. Stretched spring that is attached to it. Upon any object attached to it. Now, in our lessons to come, we will talk more and explain and have examples about each of these forces. But for now, I would really like you to have a full depth understanding of what it means when we say, when we talk about forces.